Good morning, eighth grade science class, both in person and online. Today we're going to be going over day 7 of our 10-day star review. We're almost there, guys. We're still going to be covering Earth and space, but we're going to be talking a little bit more about galaxies, solar systems in this one, okay? And light years, which is the distance we use to calculate our space because it's so vast. So number one, right off the bat, guys, we have a chart here. So let's go ahead and break that down. Now we have 4 objects here, okay? They already gave us one, the center of the Milky Way galaxy. And remember, the center of the Milky Way galaxy is not our sun, guys, the most common confusion. That's the center of our solar system, all right? The center of our Milky Way, all right? Remember, we're just one of the arms of our Milky Way spiral galaxy, so we're not even in the center, okay? So the center of our Milky Way galaxy, they're telling us is 5,000, all right, light years from Earth, okay? So when we look at this, all right, and that's center of the Milky Way, all right, Milky Way has lots of different solar systems inside of it, but in the center of our Milky Way is 5,000 light years away. Okay, up here we have something that's 0.0001 light years away. Okay, this could be anything really close to our planet. Okay, then we move over here, 4.2 light years away. Now, 4.2 light years away, we talked about it in class before, all right? But about 4 light years away, we have our next closest sun, okay? Proxima Centauri, which is the closest star other than our sun to our Earth, okay? And it's 4.2 light years away. And then down here, all right, we have something that's 60 million light years away, okay? That's a long distance. That's going to have to be something very, very far away. And it asks us, what is object 3 in this chart, okay? So first off, let's try another sun down here, aka star, center of our Milky Way galaxy, and this is very far away, okay? And this is very close. All right, so we knock things off, all right? Well, we know it's really far away, so it can't be another planet like Jupiter or Saturn, no way. A nearby star relatively close to our solar system, that is not relatively close, all right? Not relatively close to our solar system, okay? A comet, now comets are moving, so yeah, it could be a comet, all right? That's gonna be really hard to track that far away, all right? But I guess it could be. But better chance, guys, is another galaxy, very, very far away, right? Not even our Milky Way galaxy, but something further than that. And that's how vast our universe is, guys. Okay, another galaxy. So again, best choice is D. Right. Number 2, using the same chart in question 1, what is most likely object 2? So let's look at object 2. Now remember, about 4 light years away. All right, 4.2 is our other star, Proxima Centauri. Okay, so let's see if that's one of our answer choices. All right, a nearby star close to our solar system, not a black hole, not another galaxy, not Venus. Our only answer choice is B. And that's something you just have to remember for our class, guys. It is one of the sections you can put in your 8th grade science hack. It's not required for your 8th grade science hack. But these questions do come about light years. But really, guys, they want you to understand that a light year is a very large distance, okay? So, and our Milky Way galaxy is big, very big, with lots of solar systems inside. I mean, look, the next closest solar system, the next closest sun, 4.2 light years away, all right? But our entire Milky Way galaxy, all right, vast is a great expanse, and we're 5,000 just from the center, right? I think it's like close to like 10,000 or maybe close to 11 or 12,000. I have to look it up myself. Okay. And then obviously another galaxy, right? Another galaxy really far away. That would be a very large distance. Number 3, it's asking us, the following picture is the Horsehead Nebula. It's located 1,500 light years away. What is most likely occurring in the Horsehead Nebula? Well, we know that nebulas, guys, nebulas is our step 1 for the formation of a star, right? Because a collection of ball and gas eventually will get large enough to where gravity pulls it together, all right, and it can start to form a star, a sun, right? So new star formation is probably our best choice, all right? Now, if it was maybe after a star had died out, it could be a black hole, all right? But this is still a collection of gas and dust. Nothing's being really sucked in, so not really forming a black hole. Now, supernovas, I don't expect you to know what that looks like, guys, but a star explosion like a supernova, it's when a star is dying, all right? This is after all that gas and dust has been used up for its entire life cycle, which it lasts a very long time, okay? Birth of a new galaxy. Now, galaxies, guys, are gigantic, all right? Gigantic. And galaxies are made up of millions, 100,000 millions of suns and stars, okay? So the birth of, or suns and stars, same thing. So the birth of a new galaxy, guys, that's going to be way too big for this collection of gas and dust, all right? Now, all around it, you see all those little dots? Those are probably different stars in this galaxy. So this is just a new star forming. Number 4, the stars we see at night, all right? All the stars we see at night, guys, we've talked about this before, but the reason they call it the Milky Way galaxies, because at night when you look up in the sky and you see all those white dots spattered across the sky, if you're somewhere where there's not a lot of light pollution, you can really see, it looks like someone splashed milk across the sky, little dots of light all in a road, all right? And back in the day, roads or streets were called ways. All right, so they call it the Milky Way because it's like splattered with milk. But all those little dots, guys, those are just stars in our solar system. We can't see stars in other solar systems without help of a telescope or even a telescope up in space and a satellite, right? Like the Hubble. But in this situation, guys, it's everything in our Milky Way galaxy, not this in the solar system, because there's only one sun in the solar system, right? One star, our sun right now. In galaxies other than the Milky Way, this is incorrect because that's way too far away. And then if C is incorrect, well, then it can't be A and C. So our only choice is our Milky Way galaxy. But just remember, it's in the name, guys. Everything we see up in the sky, all right, that's why we call it the Milky Way galaxy, because those are all stars in our Milky Way galaxy. All right, for number 5, 6, and 7, it wants us to use this diagram. So we're going to break it down real quick, okay? Now, all it is a Hertzsprung-Russell diagram, and it's showing you our different stars, all right? So we have red giants up here, main sequence, and white dwarfs down here. On the left side, you increase luminosity, all right? Luminosity is just brightness, guys. How bright you are, okay? Luminosity. And then temperature is obviously hot or cold, okay? Just in case, right? It's hot or cold. All right, and you're going to decrease from left to right. All right, so to the right, all right, it's going to be cool. All right, and to the left is going to be hot. Okay, and luminosity, it's going to be not, all right, not bright down here, and then it's going to be very bright up here. Make sure you just break down your diagram so you can quick reference back to it so you're not confused, okay? All right, so let's answer the questions using this diagram. Number 5 asks, an astronomer discovers a new star that is very hot. All right, so again, very hot, but not very bright. What type of star does she discover? So not bright, but very hot, most likely a white dwarf. All right, make sure it's one of your answer choices. It's gonna be a white dwarf, okay? And that's going to be way up here. And that's not bright, but very hot. Okay. Good. All right, over here on number 6. Our sun is a middle-aged star with an average temperature and brightness. What type of star is our sun according to the Hertzsprung-Russell diagram? All right, so again, our star is average, meaning it's right in the middle of brightness, all right, luminosity, and temperature, all right, which makes it a main sequence star. Now, you guys probably remember that just from our studies, but just in case, that's why they give you the Hertzsprung-Russell diagram. Our star is in the middle of the main sequence, all right? Number 7, as a normal average size star progresses through its life cycle, what changes will it undergo? Well, just look at your chart, and you can remember from our studies, but if you look at your chart, it'll just keep getting, all right, less bright as you continue. It'll also cool down as you continue. All right, so we're getting less luminosity. Not the right word to put that, but just put it down for now. I get less luminosity. All right, it's not as bright. but it is, all right, going to decrease in temperature as well. So luminosity, and it's going to decrease in temperature. Let's see if one of these are the choices, all right? So let's see if it less luminosity, so it gets duller. No, it gets brighter, but it's not going to get brighter, okay? It has nothing to do with gravity. Okay, we don't see anything about the size. All right, but it is decreasing in temperature, which means it's getting cooler. That's one of our answer choices right there. Okay. All right, moving on to number 8. Which of the following galaxies is most like our own Milky Way galaxy? Well, you remember that our Milky Way galaxy is a spiral galaxy, right? And if you do this with your pen and make a spiral galaxy, okay, give yourself some, well, it's kind of like a fidget spinner. Okay. And that's gravity spinning it around, twirling it around, okay? So you can see a spiral galaxy, just like our C answer choice, all right? It's not going to be asymmetrical or elliptical or irregular. Elliptical means circular, or asymmetrical mean opposite of symmetrical. We'll cover that in number 9. And it's not going to be irregular, meaning no shape whatsoever. Our Milky Way galaxy is a spiral galaxy, number C. Number 9, look at the answer choices. Number 8, which of these is asymmetrical? So guys, remember what asymmetrical is, all right? If you drew a line through something, like a circle, all right? That's symmetry, that's symmetrical. Well, it's not a perfect circle, but it should be the same on both sides, right? If you draw a heart, draw a line through it. See how it's the same on both sides. That's symmetrical, all right? Asymmetrical, that's symmetrical, that's symmetrical. Asymmetrical, all right, will be something that's irregular on both sides. Okay, not the same, all right? So which one of these answer choices is not the same? Obviously, B, galaxy B. Make sure you choose galaxy B on number 9. You just draw some examples of regular and regular. Number 10, pulsars are dense rotating stars that emit strong electromagnetic radiation with a wavelength around 6 millimeters. Okay. Using the chart below, what type of telescope would you need to observe a pulsar? All right. So look at all these telescopes below. They tell you the range that your telescopes can handle. All right. Ultraviolet can only handle up to 0.39, visible light up to 0.74, infrared up to 1 milliliter. But anything greater than, remember, it's pointed to the right. That means greater than. Anything greater than 1 millimeter wavelength, you have to have a radio telescope for. So radio telescope is the only option here. They just want you to be able to read the chart, okay? Make sure you break it down, show as little work as you can. You're looking for 6 millimeters, so that's what you want. Number 11, you hear an astronomer on television mention that an object in space is about 10 light years away from planet Earth. The object is located where? All right, so if our Milky Way galaxy is about 50,000 light years across, I think it's like 52 light years across. That's our entire Milky Way galaxy, guys. It's huge, all right? So if it's talking about something just 10 light years away, it has to be in the Milky Way galaxy, not our solar system. Our solar system is small. It's just our sun and our planets and the moons that make up it, right? So that's our solar system, but our Milky Way galaxy is pretty large. It's going to be within the Milky Way galaxy. It doesn't necessarily need to be on the other side because it couldn't get all the way across there. Couldn't be in another galaxy. Too far to be on the other side, so not in our solar system. The only answer choice is B. This is B. All right, moving on to the back, guys, just our vocabulary. So just right off the bat, guys, our very first one, all the mass and energy in existence, guys. If it's talking about all the mass, it's talking about our universe, all right, I. Okay. The distance light travels in 1 year. Well, light in a year, that's going to be a light year. A system of bodies that revolve around a star, things like planets, asteroids, comets. All right, so think about everything that revolves around our star. It's called our solar system. The star at the center of our solar system, all right, this is known as our sun. A huge grouping of billion of stars that revolve around a center. So if it's a lot of stars, billions of stars, all right, they usually revolve around a center, unless it's like an irregular, correct? This would be your galaxy, like the Milky Way galaxy. An instrument we use to collect and magnify electromagnetic waves. This is a telescope. We're taking in lights from across the universe, and we're seeing it to a visible eye. We're making it so we can see it to our eye. A massive collection of gases that release a tremendous amount of energy. All right, so energy is a key one now. Tremendous energy. That's going to be a star. An interstellar cloud, guys. If it's a cloud, it's going to be your nebula. It's just a collection of gas and dust. That's how stars are born. And then energy waves sorted by different wavelengths into categories such as visible rays, X-rays, gamma rays, infrared. This is known as our electromagnetic spectrum. Okay. All right, that concludes day 7. Make sure you tune in tomorrow for day 8. As always, hit that bell icon, like, and subscribe. Have a good one. Be safe.